Hello everybody, today we're going to be looking at completing the square. So completing the square is a method of solving a quadratic equation. Specifically, it's how we solve a quadratic equation with square roots when it has that linear term bx in it. So we learned how to solve things like 2x squared plus 7 equals 15, right? We learned how to solve equations like 2 times x plus 1 squared plus 7 equals 15. And today we're going to look at equations that don't just have these quadratic terms, but maybe like 2x squared plus 7x plus 15 equals 0. All right, we're going to learn how to solve an equation like this using square roots. Because right now, if we tried to do that, we'd have like a regular x, a linear x, and a quadratic degree of x. And if we tried to take a square root, we would either have like square root of x in our answer, or we wouldn't be able to isolate x squared. We would just have something wonky going on there. So it wouldn't be that easy. But we need to just change how it looks first, and then we're going to try and make it look something like this. All right. I'm going to go through the 5 steps, and then we'll try 2 examples. All right. So if we need to, we divide by a first. You can skip this if a equals 1. I mean, dividing by 1 won't change anything, right? We're then going to move c to the other side, so we're going to subtract or add c to both sides. And then we're going to add b over 2 squared to both sides. That seems really random, but it actually has to do, we'll fill in this y in a moment. It has to do with the perfect square trinomial, okay? Which you might remember from Algebra 1, where if I have a plus b squared, it always works out to a squared plus 2ab plus b squared. So therefore, if I'm trying to, remember I've moved c to the other side, so at this point I have like x squared plus, let's say 6x, right, on one side of the equation. A is 1, so we can kind of ignore this a here, but it's 2b, right? That's the middle term. So if I want to figure out what should be added, I need to divide this middle term in half and then square it. So in this case, it would be 9. 6 over 2 is 3. And square that is 9. Then we're going to factor. We're going to have a squared plus 2ab plus b squared, and we're going to factor it to a plus b squared. Why? Because we can solve this with square roots, which we'll then do. All right, let's try this a couple of times. Okay, so in my first example, I'm going to write it in because we're technically doing it, but we're going to divide both sides by 1 because my a value is 1. Because remember, I'm supposed to divide a out. Okay, so I have x squared minus 10x plus 7 equals 0. Now, I'm going to subtract 7 from both sides because I need to move c to the other side. So x squared minus 10x equals negative 7. Now, I take my middle term, 10, right, or negative 10. I divide it by 2. That's negative 5. I square it, that's 25. And I add that to both sides. So I have x squared minus 10x plus 25 equals 18. The purpose of that was that now the left side here, x squared minus 10x plus 25, it'll always factor for me into a perfect square trinomial. Because we built it that way. That's what it meant to complete the square. So now I can just take the radical of both sides, x minus 5 squared, take the radical, equals the square root of 18, plus or minus. So x minus 5 equals plus or minus 3 root 2. Move the 5 over. X equals 5 plus or minus 3 root 2. All right. Let's try that again. This one's going to be a little bit harder. So here what I'm going to have to do is I'm going to have to get everything over to one side first. And I'm actually not going to get everything over to one side. I'm just going to subtract the 9x. Remember, we're going to move the c over anyway, so I'm just going to leave the c over there. So 2x squared minus 14x equals 4. Now I need to divide both sides by a, which is 2. And that'll get me x squared minus 7x equals 2. Now this is annoying, but we can handle it. 7 over 2, right? Divide it in half and then square it. So it's 49 over 4 that I'm going to add to both sides. Or I hope we're happy with 2 being 8 over 4. I think those are equivalent fractions, just so I can add these two fractions together simply more easily. X squared minus 7x plus 49 over 4 equals 57 over 4. I'm going to factor that left-hand side. Remember, it always works out this way, so it would be x minus 3 halves squared. It's always half of that 7, half of that middle term, or the square root of the last term, however you want to think about it. That equals 57 over 4. I take the square root of both sides. X minus 3 halves equals plus or minus radical 57 over 2. Add the 3 halves over, so x equals 3 halves plus or minus radical 57 over 2. All right. We can also use this technique to help us change forms. So we can easily convert from standard to vertex form this way. So if I have y equals 3x squared plus 42x plus 15, I can complete the square to help me convert to vertex form. So I'm going to start by dividing everything by a, just like I always do. So y over 3 equals x squared plus 14x plus 5. I'm going to subtract c, so y over 3 minus 5 equals x squared plus 14x. Half of 14 is 7, square it, 49. I'm going to add 49 to both sides. Y over 3 plus 44 equals x squared plus 14x plus 49. My right-hand side factors, right? So I have y over 3 plus 44 equals x plus 7 squared. That's good. That should look familiar to you when it comes to vertex form. I'm going to move the 44 over. I'm going to subtract 44 from both sides. And I'm going to get y over 3 equals x plus 7 squared minus 44. We're getting closer. We just need to get rid of that 3. So we're going to multiply the whole equation by 3. So y equals 3 times x plus 7 squared. Remember, we have to distribute. So then it'll be minus 132. And if you wanted to, this vertex should be negative 7 comma negative 132. And you could check using negative b over 2a and see if you got that correct. All right, guys, thank you and have a great day.